sample class open. I'm going to come over here to source and mouse is not wanting to cooperate. Good golly, there we go. And we'll just call this example and go on from there. Okay. So here's our example, PSVM. And what we're going to do is consider that sample code we saw a moment ago with the scanner class. All right, so we're going to include our scanner, import our scanner, and this is new scanner system.in and sout. Please enter a number. And input dot next. Okay, and then we're going to int numerator int denominator total. I don't know. Okay, so then we have our numerator, and we ask them to print out again. Please enter a divisor. And so we have our denominator and then we do the value. So we're going to say total equals numerator denominator system out print line. The value is total, right? And when we run this, by the way, I've been seeing this a lot in the programs that I've been grading. Notice I don't have a package up here. And unless you're actually going to jar up a file to me and send me a jar, please don't put the package up there. All right, so we'll go into the source, javac, example. Okay, Java example. Please enter a number. We're going to say 12 divisor 4. The value is 3. Now, what they were talking about in the code set was the scenario where you have the error. So we'll do this again. And we have 12, 0, and it throws the arithmetic exception. So here the message is divide by 0, and it gives it to us. All right, so the other way we could handle this is we would say try, and down here, put our closing curly brackets, and we say catch exception, and we handle the exception. Now, when this occurs, we could just say just get the message. You'll notice though down here that system out println value is total is zero, total is wrong. Do you guys know why it's wrong? Why it's throwing an error right now, or letting you know it's going to throw an error? Does anyone know? If you're looking at the variables up here, numerator, denominator, and total, we've declared them, but we have not initialized them, right? So you could just say that. And by initializing them all to 0, now total is done. We don't have that error anymore. Okay, so let's compile our code again. And while it's compiling, let's talk through. In order to catch the exception, we use the try keyword and the catch keyword. And the try keyword has a code block. So the try code block wraps around what we think might throw the exception. And then we catch it with the statement catch. And we're saying that the exception it throws is going to extend from the exception class. Okay, does that make sense to everyone? All right, so we've compiled it. We're going to run it again, and we'll input our numbers 12, 0, and we get this message divide by 0 was the message that was up here, and it says the value is 0. All right, let's making it a little bit more meaningful. Here, total value is 0. Let's add a statement in. An error occurred. Now when we run this, it may make a little bit more sense because it's not very reader friendly right now. Okay, so we compiled it. I'm running it again. 12, 0, and I say an exception occurred, divide by 0. The total value is 0. So we're handling the exception because mathematically we know if we divide anything by 0, the value will be 0, right? So we handle the exception, and then we let everyone know that an error occurred, and we give the value. All right, so this is one way to handle handle these types of exceptions. All right, so I'm going to jump back, and we're going to go back into this slide here. Okay, so we had the catch block that I demonstrated. We demonstrated how to use the catch block, the try block, with the curly brackets, and then we catch the object, whatever it was being thrown, with the exception class, or in this case, it could be a child of the exception class. It could be an arithmetic exception. It could be any number of things. It's always a good idea, if we know what type of exception it is, to catch that exception, because we want to pass that information along. We don't want to obscure it from the user or from ourselves, because we're all very forgetful, and you may end up forgetting at some point what type of exception was being thrown. When you look at your logs, you'll be wondering what was going on here. I don't know. It was an exception. So you want to make sure you catch with the appropriate exception, of course. All right, so the throw statement is sends the exception object out of the block method so it can be handled elsewhere. So the catch block includes the catch keyword, has the opening and closing parentheses, the exception type, and the opening and closing curly brackets for it. Okay, in this example, you have a demonstration of it. So you have some method with a return type. This is not a very good code demonstration here. This is more pseudocode than anything. All right, so you have some method that returns a type, has the parameters. There's your curly braces for the method. We're saying try, here's the curly brace, catch, some exception, close, and so forth. All right, if no exception occurs within the try block, the catch block does not execute. Let's demonstrate. So we have our IntelliJ here, and we'll run the code example again. And I'm going to say 12 and 3. The total value is 4. If the exception isn't going to be thrown, then the catch block won't be invoked. All right. If no exception occurs within the try block, the catch block does not execute. Now, I just demonstrated the get message method. This obtains information about the exception. It's always a good idea to use this to put it in the logs to catch what was going on. Within the catch block, you might want to add other code to correct the error, right? So think about it from this stance. We have the catch block. What other code could we put in here? Well, maybe we could say something like system out print line. It appears you attempted to divide by 0, right? Because we know that's what it'll say. Sout, let's say print, make that a print line. And we'll make this a regular. Please enter a new denominator. All right. Can someone tell me what you think might happen here? Let me do this again up here. Can someone tell me what might happen in this catch block now that I've done this? Any ideas? You guys are very quiet. Think about it this way. We have potentially 3 opportunities for failure. We have the potential that the next input is a 0, the denominator could be a 0, or actually 4 opportunities, right? It could be the numerator could be a letter, or the denominator could be a letter. And all we've done by catching it here is we've replicated the opportunity for them to do it again, right? So when we're thinking about our code then, what would be a better way to write that? How would we write this to make it more expressive? What do you guys think? I've said this quite a bit in class, the idea of making our code reusable. So we can make this reusable by encapsulating this piece of information into a method. And then we could call the method, and if it throws an error, we could catch the exception and say, please try again, and then have them call the method again, right? So let's do that for a moment. Let's do that. Let's have a public static, and we want this to return a number, so we're going to say int division, and we're going to give this a couple of values, right? We're going to say an int numerator and an int denominator, and we're going to say return number divided by denominator. Does that make sense so far? Now, we know this typically throws, I'm getting ahead of myself. I'm not going to do that yet. So let's take the values and actually let's change this. Let's make this a scanner. That way we can encapsulate our code a little bit more. Okay. And so now when we call this division, just passing in the input, we don't need that right there, do we? We could have int total equals 0, and then total right? Now to make this more workable, while true. So let's see. If I'm losing any of you, let me know. because I don't want to confuse any of you with what I'm doing. I can't spell. Yeah, whatever. All right. So let's think about what's going to happen in this code here. Now we've made it more fault tolerant, right? We're telling it to run this while it's true. And if an error occurs at division, it'll never call the break, right? And if it never calls the break, it's going to say an error occurred with your input. Please try again. It's going to come back up and run to the loop again. Does that make sense to everyone? All right. This is an example of your professor trying to do something on the fly and hoping it works, by the way. This is an example of trying to make your code fault tolerant. So we have, we'll debug it if we run into problems. 12, 0, an error occurred with your input. Please try again. Please enter a number. Okay. How about 0, 12? That worked fine because you can divide apparently by 12 into 0 and the total value is 0. All right, so that gives you an example then. When we do the code becomes more fault tolerant. We say do this until you get it right. Okay, so let's jump back over to our PowerPoint here. Any questions so far? Okay. So here we have their example. They're using the arithmetic exception. And that's actually, let me go back. That's actually the exception we should be using here. There we go. And of course, if we compile that, you always want to use the exception type that matches the error. If you make it too broad, then you lose information. So you get 12, 0, an error occurred with the input, please try again. Divide by 0. 12, 4, and it reaches the condition for it to exit in a fault tolerant way. All right, so this is the example that they're giving in the text. We have same process again, arithmetic exception. Exception was thrown and was caught. This is how they're dealing with it. All right, let's go on. It's useful to circumvent data entry errors. So use next line, right? So in this scenario, what are they doing? They have a number list. They have their scanner, and they're saying for x is 0, x is less than the length of this array plus x. Then they're saying we're going to do a try catch. System, enter an integer. We enter the number. If the number you enter is not going to match the number list, what do you think would happen? It's going to throw an exception, but does anyone know exactly what type of exception it would throw if the value that you enter is too large? try array index out of bounds, right? Or index out of bounds. So that's what they're doing here. They're catching that generalized exception, and then they're moving on. And then down at the bottom, some numbers, the numbers that you entered for the number list, and then they're printing them out. Let me back up. I said that wrong. They're assigning the value to the number list. So if you try to assign a value that isn't a number, it's going to fail. You get an exception. But in this instance, it would be a input type exception because the value isn't an int, right? So here they're just saying they enter WW, an exception occurred. 44, they enter XX, an exception occurred. And it just keeps going on. And it doesn't overwrite those numbers because those numbers were pre-initialized with 0. Does that make sense to everyone? What happened there? You can go back and see it again there if you have questions. There's their array index, array list of zeros. They're going to try to input. If it fails, it's not going to access that input, but it's going to go on to the next one. Now, here they're using input next line. And the reason they do that, we're using the, in our sample code that I showed you a minute ago, I use the delimiter because I think that's more readable and it handles things better. But if you don't delimit by new line, then you have to do this scenario where you're getting the next input line. Okay. All right. So there's what happens. An exception occurs and they call it. All right. So a variable declared within a block is local to that block, right? Just like any static code block that you create, anything within curly brackets, if you declare a variable in something inside of curly brackets, that variable is local to those curly brackets. And once the code moves, the execution point moves out of the curly bracket, the data in that curly bracket is now open for garbage collection. It also means that variables that are in that curly bracket are not visible unless you've declared them outside of the curly bracket. So in my example back here, I have another curly brackets, right? Same principle. I declare these numbers, these values. As soon as the method execution is done, these values are available for garbage collection because I'm inputting them out here. Total is inside this curly bracket. Now, if I declared total inside of here instead of just initializing it by passing a value, then the reference to total, it would disappear outside of the curly bracket, meaning it would be available for garbage collection. But in this instance, I declared it up here and initialized it inside of the curly bracket. But in a normal circumstance, if I do something like int I equals 1, once I get out of the curly bracket, this data is gone. Its scope is gone. Okay. So in this instance, if conversion fails, an exception is thrown, right? Inside the try block. So here we have int x, scanner input. They're taking the input from int x. They're assigning it just like I was doing earlier in the other example. An exception occurred, and then they do this here. But because x was never properly initialized, it's going to throw an error. And the error it would throw is uninitialized variable, right? We could see that example here. Let me exit out of that, jump back. If we look over here, and instead of initializing this code up here, we initialize it. Let me come back. If I do it like this, of course, I'm never going to get there because I have this while loop in place. There we go. Now if I run the code, total is going to throw a uninitialized variable, right? And IntelliJ is letting me know even before I compile that it's going to throw an error. And you can see that variable total might not have been initialized, and so it tells you that information, right? Okay. All right. So you can place multiple statements within a try block. Only the first error-generating statement block throws the exception. When a program contains multiple catch blocks, these catch blocks will be examined in sequence until a match is found for the exception type that the matching catch block executes. Each remaining catch block is bypassed. That's a mouthful. So let's go back to our example here. In this example, they have the arithmetic exception, and then they have an input mismatch exception. All right. So let's go over back to our code, and I'm going to put it back in a state that made sense. And right. And then I'm going to have another catch exception. And this is going to be my, what was it going to be? Input mismatch exception. Right? Now, let's run the code, compile it. And as we run it, we'll demonstrate what happens in this error. So I'm going to enter a Y. Oh, boy, that's not good at all. Think about what just happened here to kill that. Please try again. It's looping on me, right? Because of the while true. So input type exception. I enter a Y. It didn't catch it. So why didn't it catch it? Right? Let's put just an exception because it should have caught it. Okay. Run the program. I'm going to enter Y. Oh, this is not a good day for your teacher. I need to kill some of that code there. There we go. Error occurred. Please try again. And it's not matching the exception, is it? So we need to put a little bit more detail. This is going to be an arithmetic exception. And or what we could do is EX And that'll be fun. These are also all available methods for you. So you have get stack trace, you have get message, there's get local message, and so forth. These are all available to the exception object that you have. And when we run it now, it's going to throw a huge message. So I'll demonstrate. We'll do a Y, and the stack trace element. It's not very pretty. It's not giving me what I want. Let's see here. The way this works, we'll come back to that in a second. I know you guys are laughing right now, aren't you? It's okay. You can laugh out loud. You can say something. So the way this works is the exception, it's going to get caught in the first exception that is the most detailed. If the exception matches the arithmetic exception mistake, it'll fall into this one. If it matches the input mistake, it will fall into the second one. What you don't want to do is you don't want to put your exception, you don't want to put catch exception at the top of this list of catches, because catch exception is the broadest, and that will catch all exceptions, and you'll lose the detail. Excuse me, you'll lose the detail of it. All right, so the catch-all block, more generic the exception, it'll catch all. And then, of course, you have unreachable code, a program statements that can never execute under any circumstances. And we demonstrated that a little bit earlier with a few minutes ago with the total, where we took away its initialization. So a catch block can be written to catch multiple exception types. It's considered poor style for a method to throw more than 3 or 4 exception types. Now, the reason is that your class should really only be doing one thing. And if your method is doing more than one thing, there's probably an issue with the way you've written your code. It's okay to have an exception, but if you're throwing multiple exceptions for your class, then there's probably something wrong with the way you designed your code. It should only be really focused on one thing. It's generally a good rule of thumb to only focus on one thing at a time anyways. All right, so here we have this exception block, and we can see that this exception block is going to catch all types of exceptions. So whether it was a mismatch or a arithmetic exception, it'll catch all of those with that type of exception block. And now this finally brings us to, the finally block. All right, so finally blocks we use for actions that must perform at the end of a try-catch sequence. These are generally reserved for cleanup tasks. For example, when you're using JDBC, you'll open a connection. And these connections to the database are through I/O connections. And those connections, those I/O connections, just like with opening a file, those I/O connections have to be closed. And if you don't close them, you'll run into problems later on where the file is not accessible by somebody else, or for in the example of a database, too many openings, too many connections are created. And if too many connections are created, then you'll choke the database and people can access it, and that causes all kinds of problems. So we use the finally block to attempt to close those types of connections. And we do the finally block, um, whoops, we do the finally block simply just by typing finally and the curly brackets. And inside of here, this is where we're going to do something that we're going to uh, close a resource that we've opened. These are typically IO resources. It could be closing a database connection. It could be any number of things. Or it might be a logic scenario where if they throw a particular type of exception that you are going to just say the value for that type of data will be something else. And that could be the area that you use the finally block. One thing to keep in mind though, if you attempt to rerun logic in the finally block, for example, if I attempted to put the division logic in the finally block, all I'm doing is open myself up to issues of having to again catch the errors, the potential errors that are occurring. And this time it would have to be inside the finally block. And that's really bad code design to do that. Okay, how are we doing on time today? It is about 10 minutes out. We got about 5 more minutes here. Um, this again is dealing with the finally block. It's talking about exceptions that are caught inside of a finally block and so forth. All right, let's see here. Oh, yeah. So one area that you might want to put in a finally block is a system.exit. So for example, if your code fails or you get into a looping condition where it needs to just exit out of it, you could put a system.exit. I don't recommend putting system.exit though for things that the code needs to recover from. If you use system.exit, you're killing the application. And again, in mission critical applications, system.exit may not be the answer that you want to follow or you want to use. So the try block might throw an exception, this object that it throws, which you didn't provide a catch for, and that final block is a really good reason for that. All right, we have in our slide deck we have still quite a bit left to cover, and I don't want to get too much into the other things yet. Um, let's see. Let's go ahead and pause it at this point for right now. Let me go and stop this.